The key ideas from our previous video is that the scale factor is just the amount you divide or multiply sides of one triangle by to get the side lengths of a similar triangle. We also know if we have similar triangles to get the perimeter for one triangle compared to another. You just multiply or divide the perimeter of one triangle by the scale factor to get the other triangle's perimeter. But for area, it's a little different. It's because you're multiplying by the square of the scale factor, because you've got to multiply it once for your base and once for your height. So you're actually multiplying it by the scale factor 2 different times. So to get the area, multiply or divide the area of the one triangle by the square of the scale factor to get the other triangle's area. Okay, now we're actually going to use the similar triangle idea to help us work through a problem here. Hugo is standing next to a tall tree on a sunny day. They both cast shadows on the ground, and the lengths of each are measured. Hugo's shadow is 4.8 meters long. So Hugo is the person, and he's his shadow, which lays on the ground. Shadows do not lie in the middle of the air. They're on the ground, 4.8 meters long, and the tree's shadow is 75 meters long. So I'm marking my diagram with that information. We also know Hugo is 1.6 meters tall. Okay, so that's the information we have so far. Are the triangles formed in the diagram similar? And explain. They are similar. And here's the why behind why they're similar. Both, ideally, are making a 90-degree angle with the ground. So Hugo makes a 90-degree angle with the ground, and the tree makes a 90-degree angle with the ground, assuming the ground is level and flat. The other thing we know, and this is the tricky part, is Mr. Sunshine up in the corner here. Its rays are coming down from it and striking the earth, as long as these are within the same proximity of each other. Like one couldn't be in Vancouver and one here in St. Mary's, because this won't work. They have to be close enough together, but the angle at which the sun's rays are hitting the ground will be the same for both. Now, if you're actually at the ground looking up at the sun, that angle up towards the sun is called an angle of elevation, but we'll talk about that more when we do more problem solving. So yes, by angle-angle similarity, these triangles are similar to one another. Okay, so we have a summary here of why they are similar. Both make a 90-degree angle with the ground, and the sun's rays, which create the shadow, will hit the ground at the same angle since they are close to each other, since the two items, Hugo and the tree, are close to each other. Therefore, the two triangles are similar by angle-angle similarity. Now our next job is to find how tall the tree is. So we could let h represent the height of the tree in meters, and then we can set up our proportionality. We know that the height of the tree would correspond to the height of Hugo, and the length of the tree's shadow would correspond to the length of Hugo's shadow. So we can set up that proportion, which I'll do on the next slide. Okay, so how tall is the tree? I've got my little sketch on this slide just because I don't have the picture to go with it. I know that the height of the tree has to correspond to the height of Hugo. So we've got h compared to 1.6. The length of the shadow of the tree, so the tree information is on the top of my proportions, Hugo's information is on the bottom. The length of the shadow of the tree would correspond to the length of Hugo's shadow. Now to solve for h, to get h by itself, it's being divided by 1.6. To undo the divide by 1.6, we're going to multiply both sides by 1.6. And then we can punch that into our calculators and get an answer for the height of that tree. So I'm doing 75 divided by 4.8, multiply by 1.6, and I get 25. So therefore the tree is 25 meters tall. You could also get a scale factor here instead. You could look at the fact that you could figure out what we are multiplying 4.8 by to get to 75. So you could take 75 and divide by 4.8. So this is just an alternate solution, 75 divided by 4.8. That, on my calculator, would give me 15.625, and you don't want to round that answer. You want to keep all the digits that are there. 15.625. That means we're going to take that 1.6 and multiply to get the tree height. So the tree height h would equal the 15.625 multiplied by 1.6. But that essentially is what we're doing here. Notice that the calculation here is the 75 divided by the 48, and then we're just timesing that answer by the 1.6, just like we did there. So both do exactly the same thing, it's just one is kind of doing it in two steps, the other is setting it up just as a proportion. All right, so we need to finish that up with the therefore statement. And then it says for part C, determine the height of a nearby hydropole if its shadow is 36 meters long. So we could add the hydropole in here. So its shadow is going to be 36 meters long. Diagrams definitely are not to scale here. However, we're going to assume again 90 degrees with the ground. The angle of the sun is making with the ground is still the same as the other ones, and we can set up proportions for that. So give that a try, and then you can play the video again. Okay, I'm going to let x represent the height of the hydropole. X, the height of the hydropole, could compare to Hugo's height, and the length of the hydropole's shadow could compare to Hugo's shadow length. And then again, to get x by itself, I'm going to undo the divide by 1.6 by multiplying both sides by 1.6. That undoes the 1.6 on the left side, leaving us with just an x, and then punch that into our calculators. We get an answer of 12 here. So the hydropole should be 12 meters tall. And I'll put a therefore statement with that, and that is the end of this video. So hopefully this is all making sense for you and you understand it. You've got some problems now to work on to put this stuff together and make sure you understand before we move forward with the next lesson.